So hello to everyone who is watching this video. I'm here to explain you about tries. So what try is? Try is a data structure, is a representation of symbol table, and it means that it works with key value pairs. The interface of it is simple, just like any other interface of symbol table. We have our put that accepts string as a key and value. Well, we have get method which accepts string as a key, and we have delete method that accepts string as a key as well. So it is kind of very easy to come with conclusion that tries is a kind of special symbol table that always works with keys as that always work with string as keys. By the way, you can see the agenda in the description, and all the codes that I'm using is taken from algorithms for something, CS for something something. I'll put link in the description. You can find it in Coursera as well. So I hope it will be informative. I hope you can get something from there. So let's start. So it was kind of important thing about tries that keys are always strings. And here I wanted to give you kind of visualization of what a try is. Tries is basically a tree of nodes. The first node, empty one, is followed by sequence of characters, and the whole of this sequence of characters is actually our key, and the value that is attached to this key is stored on the last node. And you can see 1 as a string key and integer 1 as a value that is attached to this key. Another important feature of try is how it stores our keys. If the two keys have the same prefix, for example 8 and 11 have the same E as the first letter, they are not stored separately, they are kind of merged together. And here you can see another example of it. 2 and 12 have two letters in the beginning, and they are the same. And so it actually makes our try very fast and efficient in some cases, and we will discuss it in a bit later. The question that may arise here is that if we have E, O and T as first nodes, first characters that follow the root node, where are nodes, for example, for A, B, C, X, Y, Z and any other character? The answer is they exist. For example, value for node for F, it exists, but it is null. So we have created this node, we declared it, but it is null by default. We don't have any key that starts with letter F. Because of that, there is no reason of writing here. But if we add word for and value for to this try, this one will no longer be null, and we can provide characters. And of course attach a value to the last node. From this point we can see the major disadvantage of try is that, for example, we stored the node for F even when it was empty, even when this link was null, we stored them. And you can guess that we have actually some nodes for A, for B, for C, for X, Y, Z from this side, but we don't use them. They are just hanging out there, they are just waiting for their turn, and we have no benefit from them. They actually occupy the memory, and the major problem is that even if we kind of assume it to be okay for this size of try, when we work with the Unicodes, with UTF-8, there is actually a pretty big number of empty nodes, and a lot of programs they are actually broken by this number of nodes. I hope it is clear. I hope that the problem of try is clear. We will solve it in the second part of the video, and for now, let's just look at the insertion into our try. We will insert the following key value pairs: 1, 1, 2, 2, till 2, 5, and 5. When our try is created, we actually provide an empty root node for it, and then the first value is 1. We don't have any not empty link. Every link is kind of empty. Because of that, we provide new link, and here and right here 1. When we reached the end of our string, we provide the value for it. The next step, we need to insert 2. Value for 2 is 2. The next number is 3, and here we can see we are in the root node. We have actually value for t. Because of that, we are not writing extra link. We are just providing it here. Value for it is 3. The next one is 4. We don't have f in our try, so we just make new one. The last key that we need to insert is 5. We have a value for 5. We have a first node as f. Because of that, we are just writing it down there, and don't open any other link. Sorry for that. Here I wanted to explain how tries are used in real life. One of the most popular applications of try is the autocomplete system. When you search something from Google, when you type a few characters into a search bar, Google gives you kind of suggestions. What are you intending to write next? So how it works, how it approximately works. Google has some search try that stores all of the most popular queries from users. And when you type a few characters in the bar, Google outputs you most important keys that have the prefix that you typed in. So when you type how to and then D, Google just traverses the try, and then sees that after D it has a few keys that match with prefix, and then outputs it in the order of popularity. Now we are on one of the most confusing and complicated parts of the lesson, is code. We will start with the code for node class. Actually, every node has two properties. The first one is value. Value can be object, it means whatever data type you want, and in our case it is 1 for the last node and null for any other node. Then we have array that is called next, array of nodes with length r. R is 256. It is the number of characters in extended ASCII table. And if we try to visualize this using this example, we can see that every node, which kind of, this is a node, this is a node, this is a node, and even this is a node, it has this array of length r. If we try to visualize it, it means that this one node has array of length r, so kind of there is a lot of nodes around it. This end has a lot of nodes around it. Okay, and this E has a lot of number of nodes after it, which are stored in next array. Next, it means kind of next characters. For example, if we look at this end node, the only not empty link, the only not empty element in this array of nodes is actually E. Any other node is empty. We discussed it earlier, that is a real big problem. But for now, I hope that it makes sense. I hope that it is clear. So the next piece of code that we need to look at is our put method. So it's important to mention that when we instantiate our tree class, the r value is assigned to 256, and root is assigned to new node. So we create our root value, so this one, and if you remember, it has a lot of null links. So we will look at this put method right here. Let me just make it a bit bigger. So once we've called this method, this code executes, and root is assigned to whatever this routine returns to us. This step I think is clear, but what does this 0 mean? 0 means that we need to look at 0's character of our key. So if you remember, we construct our key in this way, kind of 1, and then provide value. It means that we need to care about how to insert this one, this key, this part of key, this character, into our try. We will look at this kind of in detail, not great detail, but I hope you'll just get the idea. So this method is called, this one is executed, arguments are provided, x is not equal to null because x is equal to root, we provide it here. Then d is not equal to key.length, and here is kind of important part. So d is 0. Key is equal to our 1, and it means that this c will be equal to this o. So x dot next with index of c, x dot next, we go to our array and go to index of O. So if you remember, we have a link for A, for B, for C, for every character, including X, Y, Z, and it means that we need to go to the link that belongs to our O. And we put here whatever returns this one. We provide this null link. This link is null because, well, just think about it. And we increment our d by 1. So d is now equal to 1. This one is not executed yet because we are working with this one. This method is called again. Here x is equal to null actually, and because of that we need to create a new node, and we just can insert O here because this link actually belongs to O, and so we are proceeding. This statement is false. We need to go next, and we need to go to this character of our key. D is equal to 1. We need to look at this thing. So n, we need to go x.next and n here. This one has a lot of null links again, and we need to concentrate to link that belongs to n. We also execute this one again, and we find out that it is null. We create a new node here. We can insert, we can kind of write n here because this n, this node is actually belong to n. Then what we do next? This one is false yet. By the way, we incremented our d by 1. So when we started to when we provided d plus 1 there, then after we assigned this one to whatever this function returns, we go again here and incrementing our d. So d is now equal to 3. So this is the kind of last step. X is equal to null. So we just go and write e here. And here we can see that d is actually now equal to key.length. Key.length is 3. D is 3. It means that now we provide a value. We provide a value for our x. So we go here and provide the value. And then we just return this one goes here, return this one goes kind of level up, and actually after this value is provided, we can consider part of tree to be constructed. I hope it makes sense. If you didn't get the idea, try to just look at it one more time, and I'm pretty sure that you will get it. So we remember the problem using R-way tries or 26-way tries when one node had a lot of null links, had actually array of null links. It was the major problem of our tries, and now we are having deal with ternary search try. It works out this problem pretty efficiently. On every node, maximum number of links that we are going to have is 3 nodes. So let's just look at the demo. Let's just look at the construction of this try, and I think it will make better sense than just explanation of it. So let's just look at the insertion into our ternary search try. The difference from our try is that we don't have any root empty node. If we work with this key 1 with value of 1, we need to insert it. We need to look at the first character, and it is going to be our root node O. If we don't have any links, we proceed with the middle one. After we reach the end, we provide the value to it here. The next thing to insert is actually 2. So now we start with our root node, and we are comparing this one with this one. If they are not equal, if this is not a match, we are comparing them whether T should go to the left or to the right. T is bigger than O. Because of that, we just move T to this place. So all of the T nodes are null. We are just moving down here. And of course, we are providing a value. The next step, we need to insert 3. Again, we start with root node. We are comparing T with O. It is not a match because of that we compare T with O again, and T is bigger than O, so we move to the right. Here we are comparing T with T, and we can see that it is actually a match. It means that we actually need to go down here, and here we need to compare W with H. So we found these things, these letters to match, and now we need to proceed to H and here to W. We are comparing them, and H is less than W. Because of that, we move this to the left. So I hope it doesn't go out of the range of the screen. Provide the value 3. The next thing to insert is 4. We go to our root node. We compare F with O. It is not a match, they are not equal. Because of that, we're comparing them again and see whether F is bigger or O is bigger. O is bigger. Because of that, we move F to the left. So here, all of the links is null, so we just proceed down below. We provide the value, of course. The next, we need to insert 5. We are looking at root nodes, we're comparing it, they are not equal, we move to the left. We are comparing F with F, they are actually equal. Now we are not moving to the left or to the right, we are moving down below. we're here now. We are comparing O with I. So I is actually less than O, and because of that we go to the left. 5. So I hope that it makes some sense. I hope that it is clear. If you, well, actually you can find more examples on Coursera algorithms. I hope you know where to find it, but I think you can get an idea of how to make an insertion, how to construct a TST or ternary storage trie. So now let's just quickly review the code about TST. We will start with class node as well. It is actually very similar to array trie node. The only difference, and actually very beneficial feature of TST, is that it stores only 3 links to left, mid, and right. It contains some character C, and there is a value that is attached to it. So, for example, value is 1. Well, I think it is obvious, it is clear that we solve the memory allocation problem. We don't need to store all of that null links, and here the only links we need is left, right, mid, and that's it. So let's just look at put method in TST. Actually, it is very similar. It should be very easy to understand for you, because it accepts the same set of arguments here. This put method is absolutely the same. The only difference is that root by default is null. We don't create an empty link for it, and at the beginning we look at the character, check if provided x is null. If it is, we just create a new node and assign a character. If we look at this example, we create O, we see that kind of our root is null, and we create a new node and pass a value to it. Well, not a value, we pass a character to it. Then, of course, these conditions are false when we are inserting new key, kind of inserting new key into an empty trie. The thing that we need to check is whether d is less than key.length minus 1. So it basically means that when we reach the end of our key, we don't need to put it anymore. We need to run this else statements and provide a value to it. So it just looks like that. Again, I hope it is not that bad. Well, basically it is. The thing to mention is that if this character is less than x dot character, we just move it to the left, we attach it to the left. It will be very kind of, it wouldn't be so hard for you to just simulate it by yourself, because my video is supposed to be no longer than 30 minutes. Hope it's okay. So I think we reached the end of the video. I really appreciate, guys, if you are still here. Hope it was helpful, hope it was clear. If you consider this video to be helpful, just let me know in comments below. It would be very good. So thank you for watching. Goodbye.